Hi, everyone. My name is Idowu Akinde. Everyone calls me ID. Welcome to episode 3 of season 2 in our Dear Founder series. Season 2 is all about problem validation. In episode 1, we talked about the pain meter. Episode 2, we talked about the pain opportunity matrix. Episode 3, this is also one of my favorite. I guess all of them are my favorites. Episode 3, we're going to talk about the sine wave method. Please trust me, don't judge a book by its cover. Don't dismiss this just because it sounds like one of those nerd things that people discuss in high school. Sine wave. What do you mean by sine wave? Who brings sine wave into startups, right? Please just bear with me and just follow me, right? It's really, really exciting, and it's something that opens up the world of business to the man on the street. Hopefully, like I said earlier, this will help us elevate our thinking around how we make decisions for building our startups. So without much further ado, let's get down to it. So the pain, the sine wave method is something that borrows from science, right? But it's a really useful tool for visualizing the impact of a particular problem compared to other problems. That's just what it is, okay? That's just what it is. I won't waste our time. Let's just quickly get down to it and let's see what the slide looks like. So this is the template slide, right? And this is what it looks like, right? You have the y-axis that describes impact. Don't worry, I'll make this all very practical in a moment. I will switch to the whiteboard and we'll design a new whiteboard and we'll plot 2 or 3 problems by ourselves, local and sensible to Africans. Okay, so impact. Okay, the impact of the problem, measured in whatever kilograms of CO2 offsets, dollars lost to the economy, whatever, hours of productivity lost to, whatever that is, impact. Okay, that's the y-axis. Now you're going to have multiple x-axis for as many problems as you want to model on this particular chart. So we are seeing here that there is a particular type, and each of them is a time axis. Okay, so it's chronological. Okay, we can see here that if we label the first one A and the second one B, you can see that problem A is more frequent. The cycle, there are more cycles of problem A than there are for problem B within the same time interval. Okay, you can see them side by side. However, until we plot it out, you can't know if one of them is a bigger problem, to, for instance, a state government or a national government than the other. And that's what this kind of chart helps you plot. So if we quickly switch over to the whiteboard here, okay, presenting, don't allow persistent access, create, yeah, there we go. Okay, so let's quickly draw that axis. Okay, so, oh dear, thought I was drawing an R. I have the freeform tool, but we'll do that some other time. Let's draw our y-axis here. Okay, and let's give this y-axis a label. Okay, so let's call this impact in dollars. Okay, just because I like USD. Don't mind me, I'm just messing around. All right, so let's have this here. Okay, let's say that's how this is measured. Impact in USD. Okay. Yeah, just forget about that. And then we can have multiple axes. So this is going to be slightly Africanized, right? So in Africa, we have a couple of problems, okay? In Africa, energy access, electricity is still a problem. Well, constant access, 24-hour access, uninterrupted access to electricity is uninterrupted power supply is still a problem. So let's use that as an example. Let's try, that's problem one, electricity. Problem two, fuel scarcity, okay? And if we, and it's a shame that this is a monologue, right? And if you hear me ask this question, please drop your answer in the comment section. Whenever I have an interactive session with this, whenever I ask this question in an interactive session, either one-on-one or to a group of people, I always, ask for that feedback, which is, can you give me, now that we've discussed the pain opportunity matrix and you know how to estimate the severity of pain from a scale of 0 to 10, can you tell me how painful fuel scarcity is for you? Please drop your answer in the comments. Tell me how painful fuel scarcity is for you as a Nigerian whenever it happens, okay? Just tell me, is it a 0 over 10 for you? Is it a 1 over 10 problem for you? Or is it a 10 over 10 problem? Or is it a 9, 8, 7 over 10 problem? Please drop that comment in the notes and tell me which problem you're answering. Tell me how painful power supply is for you. Tell me how painful fuel scarcity is for you. Okay, thank you. All right, so let's draw our horizontal axis. So for problem A, for the first problem, we're going to draw one axis here. And then for the second problem, we're going to draw another axis here. Okay. Now, you're going to permit me to scribble a little bit. Okay. Okay, there you go. So you're going to permit me to scribble a little bit, right? I'm going to just do this, okay? Permit my chicken handwriting, chicken scribbling. Okay. Okay, so I'm going to now bring this a little bit lower, okay? Don't forget that this is a time axis, right? So let's label this axis time, okay? And let's drop it here or here, okay? And let's copy and paste that and drop it here as well. Okay. All right. So there you go. I would have put an arrow tip there, but I don't want to waste time. Okay. We have a problem A. Okay. If I can label it, oh dear. If I can label this problem, I'm just going to call it a capital A. Okay. And let's say that this is problem A. Okay. Now we're going to label this. This is going to become problem B, but let's even plot it out first, and then we'll bring back that label. Now, problem B is of this, is like this. Okay, problem B is like this, okay? Now, okay, so problem B, this is the first wave, right, is problem A, and the second wave is problem B, okay? What you're doing here is that you're going to measure, well, this is not to scale, but you're saying here that the heights, now where's my draw? This distance, okay? In an ideal situation, if I had, a proper tools, this would be this distance here, the peak of this hill here will be exactly the same as the peak of this and this, and this, right? Like I said, ignore my chicken handwriting, my chicken scribbling. So this actually is what you are measuring as impacts, okay? So if you call these dollars, what you're saying is that if we say that this is, for instance, let me interpret this for us, okay? This is the impact and this is the time it takes. What we have just said is that, now where's that highlighter? Yes, give me the highlighter and give me a color, give me a color blue, okay? So if you plot this is one complete cycle. So this is one problem here, okay? That's the end of one instance of problem A. We said that problem A was, let's say that is power supply, okay? And we said problem B is fuel scarcity. Oh dear. There you are. Gotcha. Okay. All right. So this is one complete cycle. If you look at it, right, you could fold this and you get something like an egg or a potato. This is the second complete cycle. This is the third complete cycle. This is the fourth complete cycle. Okay, so in this, if we say that this time interval is, just for discussion purposes, this is a year, right? We're saying that in Nigeria, right, we're saying that total blackout, oh, beautiful, this should have been, oh dear. I'm going to call this, okay, I'm going to call this nationwide blackouts. Perfect. All right. So we're saying that in the space of the average year, in the space of a year, right, averagely, Nigeria experiences 4 nationwide blackouts. 1, 2, 3, 4. Measured by the number of times that this cycle occurred. Okay, so that's just that. You can see that this one didn't finish. So let me call this, we saw that this is 4.5 occurrences of a nationwide blackout. That's what this chart has told us, okay? Now, let's see what this other one tells us. Let's change that to red, okay? This particular one, how many complete cycles can we find? There's one complete cycle here, right? Okay, and then there is a half. So this is a 1.5x, okay? So what we're saying now is, if this impact, right, the impact of this, every time, if I do this selection and I lift this here, right, and I say, every time this problem occurs, can I label this gentleman? I don't think so, okay? Every time this guy occurs, it costs the economy, for instance, let's say, just for discussion purposes, $3 million, right? 3 million USD, okay? Okay, let's just say that that happens, okay? What we're saying is that in a year, it costs the economy, for one cycle, it costs the economy, it costs the Nigerian, a nationwide blackout costs the Nigerian economy $3 million. And in a year, we recorded 4.5 episodes, right? Of, 4.5 episodes on the average of a nationwide blackout. That means in a year, Nigeria, this problem has cost Nigeria 3 million times 4.5. Where are you? Those of you that are math whizzes, right? That sounds to me like a 13. Am I right? I think so. 0.5. If I'm not right, Mr. Famuyiwa will have my neck. For those of you that understand the joke. All right. Let's just duplicate this arrow, this double-sided arrow, and drop this gentleman here. Now, let's just say that it's here as well. Now, this time around, this particular problem B, okay, this one is $3 million in impact, right? Let's just say that this one is $100 million in impact. Okay, we use the color red for this. So let's say that, that's not what I should be doing. Let's say that this one is $100 million in impact every time it occurs, okay? The first scarcity. The nation loses $100 million, maybe due to lost productive hours, and so on and so forth, right? So $100 million lost to this particular problem for each complete cycle. So in a year, what is the impact to the economy? I think this one is also clear, right? So here we have this is 100 by 1.5. So problem B is, so I mean, the results are self-explanatory, right? Problem A costs the Nigerian, again, this is entirely fictional. Please, nobody should come for me. This is entirely fictional, right? Problem A, our theoretical, hypothetical nationwide blackout problem, costs the Nigerian economy $3 million every time it occurs. And in a year, we measured and found that it occurs 4.5 times. That tells us that this thing costs the Nigerian economy $13.5 million, just on average, right? Maybe this is taken over a 5-year or 10-year period. On average, this thing costs the Nigerian economy $13.5 million, okay? The second problem, fuel scarcity. Whenever there's fuel scarcity, people spend productive time that they should spend at their workplaces, on filling stations, on queues. People are not able to work as productively as they could because their generators are on versus the national grid versus the power grid, lost productivity. You calculate all of that value together and you get $100 million whenever it occurs. But you said this happens 1.5 times every year. Again, maybe it's taken about an aggregate number of times, and then you have $150 million. So the question I have to you is, which of these problems would you pursue? Right? So again, like I said, these are some tools, techniques, tricks that we use to filter when we have a number of problems to pursue. So it's obvious here that if I am CEO of an organization and I have a product manager or a business, yes, a product manager, right? A business manager, product manager that wants to present a variety of initiatives to me. If you come to me with this kind of analysis, I mean, end of discussion, we know what to chase, right? Why chase 13.5 when we can chase 150? So obviously that's the problem. Of course, there are many other variables that will determine which of the problems you solve. But by and large, at this high level, this is the sine wave method of problem analysis. Thank you very much once again for tolerating my hallucinations. I hope this has been a bit useful to you. See you on the next one. Bye.